Hey, welcome to Algebra 2, Lesson 2-4, Complex Numbers and Operations. In this lesson, we'll be able to solve problems and complex numbers. The lesson vocabulary would be complex conjugates, complex number, imaginary unit 1. So, as you can see, we're going to talk about complex numbers and operations here. Let us start thinking about this, explore, and reason. A math class played a game called Solve It, You're Out. At the start of each round, students chose a card from a deck marked with integers from -5 to 5. When an equation is shown, any student whose card states the solution to the equation is eliminated. 5 students remain. So Mercedes, Fatima, Steve, Elijah, Aubrey are the 5 students who remain right now. And they each have these integers, right? So let's think about the situation. The next equation presented was x squared equals 9. Which students was eliminated? So when an equation is shown, like x squared equals 9, any student whose card has the solution would be eliminated. Whoever survives will be the ones who do not have that solution. So the goal is not to be one of the solutions, right? So first of all, we want to figure out the solutions for x squared equals 9. It's simple, right? We have x squared equals 9. In order to solve for x, we're going to square root both sides. And we have x is equal to plus or minus 9. Both negative and positive 9 will be squared to get a positive 9. Not 9, 3. Both positive and negative 3 would be squared to result in a positive 9. So who have the card with a -3 and a +3? Mercedes and Fatima. So we can explain using words. We will say that Mercedes and Fatima should both be eliminated because x is equal to -3 and 3. Okay, I'm gonna move the answer for A here. Okay, what about part B? In the next round, the equation presented was x squared equals -4. Elijah thought he was eliminated, but this is not the case. Why? Elijah thought he was eliminated, but he wasn't. Why? Because -2 times -2 is +4, not -4. So -2 is not going to give a -4, right? Elijah is incorrect because -2 squared is not equal to -4. It is actually +4. All right, so part C. What is true about solutions to x squared equals a when a is a positive number? When a is a negative number? What about when a is equal to 0? So let's think about solutions for the quadratics. When a is a positive number, when we have a square and then it's if a is positive, what can we say about x? Can x be positive? Yeah, positive times positive is positive. Can x be negative? Yeah, negative times negative is a negative. What if when a is a negative number? Then if a is negative, then your x can only be nothing. No square will be a negative number. So there is no real number, real solution. What about when a is equal to 0? X has to be 0, right? There's only one number, which is 0, that makes the square true. So we have 3 different scenarios here. Let's summarize and write it down. When a is greater than 0, which is positive, there will be 2 solutions to the equation. Which is going to be positive a and negative square root a. And then I'm going to make this even smaller. No, that's too small. And when a is less than 0, there are no real number solutions. And finally, when a is equal to 0, there will be only one solution, which is x equals 0. Okay, so this is a good concept to think about. What if we determine a certain letter or a certain number to be a solution for when a is a negative number? So that's what we're gonna think about. Okay, so the essential question for this lesson would be, how can you represent and operate numbers that are not on the real number line? We're going to think about some possibilities that are not on the real number line, which means we're not going to think about real numbers. We're going to think about possible solutions for non-real numbers. Is that even possible, right? Okay, let's think about example 1. Solve a quadratic equation using square roots. How can you use square roots to solve each equation? Let's look at part A. X squared is equal to 16. So in this case, you will solve by square rooting both sides, just like we have solved in the previous problem, right? Notice that each side of the equation involves a perfect square. X would be just x. If we square root x squared, it would be x, and x would be either positive square root of 16 or negative square root of 16, so that would be plus or minus 4. So our solution could be both positive and negative 4. What about x squared equals negative 9? In this case, we can just say that x is going to be positive or negative square root negative 9. And if we try to separate it and make it more simple, we can maybe go as far as separating negative 1 times 9, right, to make a negative 9. And we can square root positive 9 and get a plus and minus 3, but we still have that square root of negative 1 here. So the solutions of the equation x squared equals -9 are not real numbers, but are part of a number system called a complex numbers. Okay, so square root -1 will exist as long as we use square roots and squares, right? So it will be there, but what are we gonna call them? The solutions are not real numbers, but we will see these type of problems where when we solve for x, it's going to be a square root of a negative number, which is not possible, right? In the real number system. So we're gonna think about complex numbers. We're gonna say the number square root -1 is not possible, but we're gonna call it an imaginary unit I. Okay, so square root -1 is equal to I. Replacing this with I will allow you to write solutions to the equation of x squared equals -9 as 3i and -3i, right? So as long as you have this factor, you'll be able to rewrite it as I or -I, okay? So here, let's think about try number 1, A and B. Pause the video and come back when you're ready for solutions. Are you ready? Okay, so let's solve these equations. X squared is equal to -5. We want to write the solutions using the imaginary unit I. So that means we want to find a square root of -1, right? We want to factor it out. So first of all, we can solve part A as square root of x squared is equal to square root of -5, which means x is going to be plus or minus square root of -5, and that's not a real number, right? So you can factor the 5 out and say square root of +5 times square root of -1 is going to be the same as square root of -5, right? And so you can say square root of plus or minus square root of 5 times I would be your solution. So in order to prevent confusion where you don't want to write I inside the square root, we're going to move I in front of square root so that we clearly define that I is multiplied with by the square root of 5. Okay, so I should be written in front of the square roots. Okay, part B, you're gonna use the same way. X is going to be plus or minus square root of -72. And that's going to be plus or minus square root of 72 times square root of -1. And this one we can factor out, right? Yeah, so this one in this case, we can factor out using perfect squares. So what are some perfect squares we can think of that's close to 72? 49 is, so 49 would have a root of 7. What about 8? 8 squared would be 64, and then 9 squared would be 81, right? But can we factor 72 out? Let's factor 72. 72 divided by 2 is 36. And then divide this by 2, 18. Divide that by 2, 9. Divide that, factor it out completely, then you'll be able to see, oh, this could be rooted out. So 2 times 3 would be 6. And so you want to multiply these factors. 2 times 2 times 3 times 3. And then that means you're going to factor them out, which means 2 times 2 times 2 times 3 times 3, which is 72, would be able to factor it out as 2 times 3, right? And that would be 6. And then you still have square root of 2. And then you have the imaginary unit. So the proper way to write it would be plus or minus 6i. So order them. And then square root 2. So square root comes in at the very last because because you have the square root, and you may create confusion with the numbers after that being inside the square root. Okay, so if you have any numbers that are factored out from the square root, write it in front of the square root. Okay, so that was example 1. Try it number 1. We learned how to solve equations involving imaginary numbers. Let's continue with example 2 in the next video.